Multiplying monomials. A monomial is a number, a variable, or a product of a number and one or more variables with non-negative integer exponents. It only has one term. A constant is a monomial that is a real number. A plain number. Okay, so 3 will be a monomial. Alright, constants, which are without variables, okay, are also considered monomials. A monomial could look like this: x. It could be the product of a number and one or more variables, so 3x. Or how about 3xy? As long as there is not a negative integer exponent. Alright, write all of these down. Above them, I want you to write, like I did, monomial, yes or no. And then write them all out, and then we'll go through them. The number 10, is this a monomial?
Yes.
Yes, it is a constant. Constants are monomials, so this would be a yes. F plus 24, is this that fits the definition?
Yes.
Let me read the definition of monomial. A number, variable, or a product of a number and one or more variables.
No.
Is addition a monomial?
No.
No, so this is no. H squared.
No.
Let me read the definition. A number, variable, or product of a number or one or more variables with non-negative integer exponents.
The next one. Oh, no.
This is a product of variables.
Yes.
Right? H times H. So it's yes. How about just J?
Yeah.
Yes, it says a variable. Negative x plus 5. No, this is addition.
Yeah.
This is yes. Okay? This is a product of a number and several variables. Okay? But it is just one term. So it is yes. 23 ABCD squared.
Yes.
Yeah.
Yes.
We just said that.
X,
No, I'm talking about
XYZ squared over 2.
No.
Oh,
No.
Okay, then the
it's
next
not a
one
product.
is yes.
No.
It's
both no.
it's yes.
How's that?
Yes,
not a product.
that was right.
It can be.
What? You can.
We'll work on that later. Okay, but you can make it's a constant is in the denominator, so that's okay.
Times 2, and then it turns into.
Well,
Like the.
okay. Could I write it like this? 1/2 XYZ squared.
Yeah.
Isn't that a monomial?
Yeah.
So how is this any different?
I don't know.
Because you're timesing by half is the same thing as dividing by 2, right?
Yeah.
Yeah, there you go.
So
MP over N.
Yeah, no.
This is no. Okay? This is no. It has a variable as a denominator. When you have a constant as a denominator, that's okay. Because I can say that's like timesing by half. But if you're dividing by a variable, that means it's not a monomial. Okay? And you'll know why later on. Okay? Because N would have like a negative exponent. Okay? Because you could write it like this. It's the exact same thing. N with a negative 1 exponent just means you're dividing by N. Right? It says you cannot have a negative exponent. So that's why it's a no. Alright, write this. This is just the parts to a monomial. X is your base. The exponent 3. You could have something like this, 3 to the 4th power. Okay, it has 4 factors because it's 3 times 3 times 3 times 3, which 3 times 3 is 9. 9 times 9 is 81. Write this down. When multiplying monomials, okay, if they have the same base, b to the 3rd power times b to the 5th power, what we do, we keep the same power and we just add the exponents. So b to the third power times b to the fifth power. Same thing as b to the eighth power. X to the fourth power times x to the ninth power. Again, we add exponents. When multiplying monomials, we add exponents. Okay, as long as they have the same base. 4 plus 9 is 13.
Hey, good job, Chucky.
X to the 13th power. 6 in cubed times 2 in the 7th power. Right? We can rearrange this as 6 times 2. And then in cubed times into the 7th power. Well, 2 times 6 is 12. When multiplying, you just add the exponents. So this is into the 10th power. All right, we have 3pt cubed times p3 t4. All right, so what we do, we take 3 times 1, okay, because we assume there's a 1 right there. That's just 3. We take p times p cubed. We add, when multiplying bases, we add exponents, so that's p to the fourth. T cubed times t to the fourth power. Again, we're multiplying bases, so we add exponents to the 7th. P here is raised to the first power. If there's no exponent, then it's raised to the first power. Write this down. We have b cubed raised to the fifth power. This is what we call power of a power. We're raising a power to a power. Earlier, when we were multiplying bases, we added exponents. Now we're raising to a power, so we take b and we multiply the exponents. 3 times 5. B, okay, raised to 3 times 5. Okay, that is equivalent to b to the 15th power. So we just multiply the exponents. If you're raising the power to the power, you multiply exponents. Here we have 2 being raised to the third power, then squared, then raised to the fourth power. So we just multiply those.
24.
It is to the 24th power. If you calculate what 2 to the 24th power is, it's equivalent to this. 16,777 216. That's what 2 times itself 24 times it.
Hey, that wouldn't be 6.
You're right. It's 16,777,216. Write this down. This is a times b raised to the m power. So what we do is we distribute the m. We raise everything to the m power. So it's a to the m power and b to the m power. We have negative 2 times x, y cubed, raised to the fifth power. So we distribute the 5. We raise everything to the fifth power.
So,
Now y was already cubed, so we take 3 times 5. We raise it to the 15th power. Negative 2 to the fifth power is negative 32. Because 2 times 2 is 4. Right? 4 times 4 is 16. 16 times 2 is 32. X to the fifth power, y to the 15th power. Write this down. What we do, this just asks us to simplify. So we work out everything. Okay, we are raising this to the second power, so we go ahead and distribute the 2 first. 4 times 2 is 8. We go ahead and distribute the 2 here. That gives me negative 2 squared, y squared. You're raising that to the third power. So negative 2 to the 6th power, y to the 6th power. Now you're multiplying this together. So you multiply like terms, the like variables. So you have 3 squared, which is 9. Negative 2 to the 6th power is 64. Because negative 2 to the 5th power was negative 32. X squared because there's no other x. And then you're multiplying y to the 8th and y to the 6th. When you're multiplying bases, you add exponents. So that gives us 14. So then you do 9 times 64. Gives me 576 x squared y to the 14th power.
Holy cow.
You simplify until there is no multiplying of powers, till there's no raising powers to powers, okay, until everything has been simplified. Every base can only appear once. Alright, this is number 43 in the homework problems. So you're going to see problems like this.
Wait, there is no 43.
I know, but it's one of, yeah,
Is it?
it's one of the homework problems.
Is it on there?
Okay, so what you do, you distribute the 3 out first. Okay, we raise everything in here to the 3rd power.
Wait, why were you doing it to the 4th? Oh, I see. Alright.
H to the 4th power times 3, that's going to be h to the 12th power, right? You're multiplying exponents. First thing you do is raise everything to the 3rd power in there, so negative 2 to the 3rd power times g to the 12th power, h to the 3rd power. We're raising that to the 2nd power. So we have negative 2 to the 6th power,
This is all confusing with the letters and stuff.
g to the 24th power, h to the 6th power. You guys be quiet. And then you multiply it with this.
Hold up. You should pause it right now.
Wait, give me a second. I'll get it.
Hold on, pause it.
So we take now we just get to where every variable appears once. 2 cubed times negative 2 to the 6th power, that equals 512. Because that's, yeah.
Wait, to the what power?
Third power.
You have 2 to the 3rd power times negative 2 to the 6th power.
Wait.
That's crazy.
G to the 3rd power times g to the 24th power. Remember, when multiplying bases, we add exponents.
Oh, I didn't do this.
Again, h to the 12th power times h to the 6th power, so h to the 18th power.
Crazy. I know I'm gonna mess up on.
Here's your assignment.